Hello everyone, welcome back to my YouTube channel Physics Unification. In the last video, we discussed a chapter Electric Charges and Fields from the second PUC. That one is the first chapter. Today, we are going to deal with a new chapter that is Optics and Optical Instrument. First of all, what do you mean by optics? That one is the branch of physics which is concerned with light and its behavioral pattern and properties. There are three types of optics are there. First one, it is geometrical optics that gives the study of light as rays. Second one, it is physical optics that gives the study of light as waves. Third one, it is quantum optics that gives the study of light as particles. In optics, it found in variety of technologies and everyday objects. Includes mirrors, lenses, telescopes, microscopes, lasers and fiber optics. Let me know the concept of optical instruments. That one is the device that processes light waves either to enhance an image, for viewing, or to analyze and determine their characteristic properties. Example, microscope, telescope and camera. Optical instrument ಅಂದ್ರೆ ಏನು? That one is the device. It processes light waves either to enhance an image. Light waves ಅನ್ನ ಏನು ಮಾಡುತ್ತದೆ? Enhance ಮಾಡುತ್ತದೆ for viewing, ನೋಡೋದಕ್ಕೆ, or to analyze and determine their characteristic properties. Characteristic propertyನ ಅನಲೈಸ್ ಮಾಡಲಿಕ್ಕೆ ಯೂಸ್ ಮಾಡುವಂಥ ಡಿವೈಸ್ನ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ? ಆಪ್ಟಿಕಲ್ ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ಸ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಯೂಶ್ವಲಿ ಯಾವುದು ಆಪ್ಟಿಕಲ್ ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ಸ್? ಮೈಕ್ರೋಸ್ಕೋಪ್, ಟೆಲಿಸ್ಕೋಪ್ಸ್ ಮತ್ತು ಕ್ಯಾಮ್ರಾ ಅಂಡ್ ಸೋ ಆನ್. Next concept, it is reflection of light by spherical mirrors. Reflection means reflection andrenu? That one is the bouncing back of light to the same medium. Light ಬೌನ್ಸಿಂಗ್ ಬ್ಯಾಕ್ ಆಗಿ ಸೇಮ್ ಮೀಡಿಯಮ್ಗೆ ಬರೋದನ್ನು ನಾವೇನಂತ ಹೇಳ್ತೀವಿ? ರಿಫ್ಲೆಕ್ಷನ್ ಆಫ್ ಲೈಟ್ ಅಂತ ಹೇಳ್ತೀವಿ. ದಟ್ ಒನ್ ಇಸ್ ಬೈ ಸ್ಪೆರಿಕಲ್ ಮಿರರ್ಸ್ ಅನ್ನು ನಾವಿಲ್ಲಿ ಸ್ಟಡಿ ಮಾಡ್ತಾ ಹೋಗ್ತೀವಿ. ಫಸ್ಟ್ ಒನ್, ಇಟ್ ಈಸ್ ಆಂಗಲ್ ಆಫ್ ಇನ್ಸಿಡೆನ್ಸ್. ದಟ್ ಒನ್ ಇಸ್ ದ ಆಂಗಲ್ ಬಿಟ್ವೀನ್ ಇನ್ಸಿಡೆಂಟ್ ರೇ ಆ್ಯಂಡ್ ದಿ ನಾರ್ಮಲ್ ಟು ದಿ ರಿಫ್ಲೆಕ್ಟಿಂಗ್ ಸರ್ಫೇಸ್. ರಿಫ್ಲೆಕ್ಷನ್ ಅಂದ್ರೆ ಏನು? ಆಂಗಲ್ ಆಫ್ ರಿಫ್ಲೆಕ್ಷನ್. ದಟ್ ಒನ್ ಇಸ್ ದಿ ಆಂಗಲ್ ಬಿಟ್ವೀನ್ ರಿಫ್ಲೆಕ್ಟೆಡ್ ರೇ ಆ್ಯಂಡ್ ದಿ ನಾರ್ಮಲ್ ಟು ದಿ ರಿಫ್ಲೆಕ್ಟಿಂಗ್ ಸರ್ಫೇಸ್. Next one, it is laws of reflection. This one is very important for 2 marks. The angle of reflection equals to the angle of incidence. That one is I is equals to angle of reflection R. Here IR, that one is the incident ray and which is reflected back to the same medium. That one is the reflected ray and which makes an angle R with the normal ray. Second law of reflection, it is the incident ray, the reflected ray and the normal to the reflecting surface. Incident ray, normal ray ಮತ್ತೆ reflected ray to the that surface at the point of incidence lie in the same plane. ಇವು ಮೂರು ಲೈನ್ಸ್ ಸೇಮ್ ಪ್ಲೇನ್ ಮೇಲೆ ಲೈ ಆಗಿರುತ್ತೆ. Next one concept, it is sign convention. Here sign convention is very important for solving the problems and to deriving the some derivations. All distances are measured from the pole of the mirror. Let us consider this one is the mirror. This one is the middle point. That one gives the pole of that mirror. All distances are measured from the pole of the mirror. ಆ ಪೋಲ್ ಆಫ್ ದಿ ಮಿರರ್ ಇಂದಾನೆ ನಾವು ಪ್ರತಿಯೊಂದು ಡಿಸ್ಟೆನ್ಸ್ ಅನ್ನ ಮೆಜರ್ ಮಾಡ್ತೀವಿ, ಆರ್ ದಿ ಆಪ್ಟಿಕ್ ಸೆಂಟರ್ ಆಫ್ ದಿ ಲೆನ್ಸ್. ದ ಡಿಸ್ಟೆನ್ಸಸ್ ಮೆಜರ್ಡ್ ಇನ್ ದಿ ಸೇಮ್ ಡೈರೆಕ್ಷನ್ ಆಸ್ ದಿ ಇನ್ಸಿಡೆಂಟ್ ಲೈಟ್ ಆರ್ ಪಾಸಿಟಿವ್. ಇನ್ಸಿಡೆಂಟ್ ಲೈಟ್ ಯಾವ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಮೂವ್ಮೆಂಟ್ ಆಗ್ತಿರ್ತದಲ್ವಾ, ಅದೇ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ನಾವು ತಗೊಳ್ಳೋ ಡಿಸ್ಟೆನ್ಸ್ ಅನ್ನ ಪಾಸಿಟಿವ್ ಆಗಿ ತಗೋತೀವಿ. The distances measured in the opposite direction as that of the incident light are taken it as negative. Incident direction ಅಲ್ಲಿ ಮೂಮೆಂಟ್ ಆಗ್ತಿದ್ರೆ ಪಾಸಿಟಿವ್ ತಗೋತೀವಿ, ಅಪೋಸಿಟ್ ಡೈರೆಕ್ಷನಲ್ಲಿ ಮೂಮೆಂಟ್ ಆಗ್ತಿದ್ರೆ ಆ ಡಿಸ್ಟೆನ್ಸನ್ನು ನಾವು ನೆಗೆಟಿವ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ. ದ ಹೈಟ್ಸ್ ಮೆಜರ್ಡ್ ಅಪ್ವರ್ಡ್ ಡೈರೆಕ್ಷನಲ್ಲಿರೋ ಹೈಟ್ಸನ್ನು with respect to x-axis and normal to the principal axis of the mirror or lens taken it as positive. Upward direction height positive ಆಗಿ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ. The heights measured downwards are taken it as negative. ಡೌನ್ವರ್ಡ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿರೋ ಹೈಟ್ ಅನ್ನ ನೆಗೆಟಿವ್ ಆಗಿ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ. Next one concept, it is focal length of spherical mirror. One it is concave mirror, another one it is convex mirror. The reflected rays converge at a point F on the principal axis of a concave mirror. Concave mirror ಅಲ್ಲಿ ಏನಾಗಿರುತ್ತೆ, ಒಂದು ಪ್ರಿನ್ಸಿಪಲ್ ಆಕ್ಸಿಸ್ ಮೇಲೆಯ ಪ್ರತಿಯೊಂದು ರೇಸ್ ಕನ್ವರ್ಜ್ ಆದಂಗೆ ಅಪಿಯರ್ ಆಗುತ್ತೆ. The reflected rays appear to diverge from a point F on its principal axis of a convex mirror. ಕಾನ್ವೆಕ್ಸ್ ಮಿರರ್ ಅಲ್ಲಿ ಪಾಯಿಂಟ್ ಎಫ್ ಇಂದ ಪ್ರತಿಯೊಂದು ರೇಸ್ ಡೈವರ್ಜ್ ಆದಂಗೆ ಅಪಿಯರ್ ಆಗುತ್ತೆ. Here F is the principal focus of the mirror. The distance between the focus F and the pole P of the mirror is called it as focal length. Next one it is to prove F is equals to R by 2 or R is equals to 2F, and this one is very important for 3 marks. Here M be the mirror and C be the center of curvature and R be the radius of curvature of that mirror. Consider a ray parallel to the principal axis. This one is the ray and this one is parallel to the principal axis and which is striking the mirror at M. CM is perpendicular to the M. That one is the mirror. And theta be the angle of incidence. Then MCP is equals to theta and MFP is equals to 2 theta. That one is the outside angle which is equals to the sum of interior angles. That one is outside exterior angle is 2 theta which is equals to the sum of interior angles. That one is theta plus theta. Now what we have to do? Apply tan theta. Tan theta which is equals to tan theta. Theta is here and just consider the triangle MCD. Tan theta becomes MD divided by CD and tan 2 theta by the triangle MFD which gives MD divided by FD. Now theta is very small, so tan theta can be considered it as small theta which is equals to the MD divided by CD and 2 theta is equals to MD divided by FD. Now this equation becomes written as equation 1 and equation 2. Let us consider equation 2 and which implies 2 theta is equals to MD divided by FD and apply value of theta from the equation 1 it has MD by CD in equation 2, then which gives 2 into MD divided by CD which is equals to MD divided by FD. Here MD gets cancelled each other and which gives 2 divided by CD is equals to 1 divided by FD which implies 2 times FD is equals to CD. Here value of FD which gives the focal length F. So FD 2 times of F is equals to CD. That one is CD is equals to radius of curvature R is equals to R. That is the radius of curvature R is equals to 2 times that of the focal length F. This radius of curvature is equals to the 2 times that of the focal length, and this derivation is important for 3 marks. Next one, it is image formation by mirrors. If ray starting from a point meet at another point after reflection or refraction, reflection agi ಅಥವಾ refraction agi ಒಂದು ಪಾಯಿಂಟ್ ಅನ್ನು ಮೀಟ್ ಆಗ್ತದೆ, that point is called image of the first point. That image is real if the rays actually converge to that point. ಕನ್ವರ್ಜ್ ಆದರೆ ನಾವು ಆ ಇಮೇಜ್ ಅನ್ನು ರಿಯಲ್ ಅಂತ ತಗೋತೀವಿ. The image is virtual if the rays do not actually meet but appear to diverge from the point when produced backwards. We are already familiar with these concepts in class 10th. Please go through it. Next one, it is mirror equation. That one is the relation between object distance u, image distance v and the focal length f. Let us consider two right angle triangles A', F and MPF. By similar triangle property, what we can write, A', B' divided by PM is equals to B', F divided by P into F. Here PM, which is equals to AB. PM is equals to AB. Then B', A' divided by AB is equals to B' F divided by P into F. And B' F can be written it as B' P minus F P divided by P into F. This is called it as equation 1. Now, since triangle APB and triangle A', those are right angle triangles, and also A', and AB are also similar to each other. By this one, what we can write, A', divided by AB is equals to B' P divided by BP. That is A', B' divided by AB is equals to B' P divided by BP. This is equation 2. By comparing equation 1 and 2, what we can write, B' P minus F P, this one is equation 1, divided by P F is equals to B' A' divided by AB. In place of B' A' divided by AB, what we can write, B' P divided by BP, which is equals to B' P divided by BP. This is called it as equation 3. Now apply sign convention. Here, according to sign convention, what we can take, light travels from object to the mirror MPN. Here it is MPN. We can take it as positive. Means the ray which is traveling along the incident light, that one we can take it as positive. To reach the object AB, image A', B' and focus F from the pole P, we have to travel opposite to the direction of the incident light. Means the ray which is opposite to the incident light, we can take it as negative. Hence, what we can take, B' P is equals to minus V, and FP, that one focal length is also opposite to that of incident light. So what we can take, minus F, and BP is equals to minus U. Now equation 3 can be written it as equation 3. Which one it is equation 3? B' P minus FP divided by PF is equals to B' P divided by BP. This one is equation 3. Now what we can take, B' P, it is minus V, FP, that one is focal length which is in negative direction, that one gives minus f. P F, or almost that one is equals to Fp, that one is minus F. Next Bp, it is minus U. Now substitute these values B dash P, Fp and Bp in equation 3, then what we will get? Minus V minus of minus F divided by minus F is equals to minus V divided by minus U. Now minus V, minus into minus, plus F divided by minus F minus F. Denominator split ಮಾಡಿ ಬರೆದಿದ್ದೀನಿ, is equals to minus minus gets cancelled, which gives V by U. Now it becomes minus V by F minus 1 is equals to V by U. Now it becomes minus minus gets cancelled, so which gives V by F plus 1 plus F minus F, which gives minus 1, which is equals to V by U. Then what we can write? I will write here. Then which gives V by F on right hand side, which contains V by U, positive sign. When it comes to left hand side, what becomes? Minus V by U is equals to plus 1. Then here VV is common, just take outside, then what we will get? 1 by F minus 1 by U is equals to 1. Then 1 by F minus 1 by U is equals to 1 by V. Then what we can write? Therefore 1 by F is equals to 1 by V plus 1 by U. This one is the expression for mirror. That one is the mirror equation. And it also called as relation between V, U and F. And this derivation is very important for 5 marks. This mirror equation is very important for 5 marks derivation and also for problematic part. They will ask problems from this equation mainly. Next one concept, it is linear magnification. It is the ratio of height of the image to the height of the object. That one is magnification M is equals to minus V divided by U. Why minus sign here? That one is image distance, whatever we can taken it as opposite direction that of the incident light. That one we can taken it as negative. That one is H dash divided by H. Height of the image to the height of the object, it is called as linear magnification. If linear magnification is greater than 1 or magnitude of V is greater than magnitude of U, then the image is magnified. Magnify agide anta artha, enhance agide anta artha. If magnification is less than 1 or magnitude of V is less than magnitude of U, then the image is diminished. Diminished andre small agide size inda anta. If magnification is equals to 1, then the size of the image is same as that of the object. At the finally what we can take? If M is positive, image is erect and virtual. If M is negative, image is real and inverted. Which completes the first part of the chapter, ray optics and optical instruments. In the next video, we can discuss some more concepts from this same chapter. Those are refraction of light, consequence of refraction of light, internal reflections, and the concept of critical angle and the relation between critical angle and refractive index, and some problems based on these topics. Thank you. Stay tuned. Like, share and subscribe my YouTube channel Physics Unification. If you have any doubts regarding these concepts, please drop a comment in a comment box.